Hi, hello everyone. Welcome back to my channel. So in last class we are discussing cantilever beam with point load at free end. So in that we completed some how to draw a shear force and how to draw a bending moment diagrams. For that we done a simple derivation for that in order to solve a problems. So now we are going to study a cantilever beam with uniform distributed load. So in last class we discussed point load. First now here uniform distributed load. That means consider one element in that load is acting as a uniform distributed load, not a point load. Previously we studied point load. So this is our diagram for the cantilever beam with uniform distributed load. So cantilever beam is what? One end is fixed, another one is free end. So at free end load is acting. What load? Uniform distributed load is acting at the free end. So this is our figure. So next, now for that we want to consider the portion CB. So before that we want to give the notations A, B, C. So first we want to give here A and last we want to B and next to C. So if any loads is acting here D, at that time we use D, E, F like that. So now A, B, C. So first of all we want to consider the portion CB. So for that we want to do calculation of shear force and bending moment diagram. For the calculation diagram of shear force and bending moment diagram, we want to do the shear force and bending moment. So for that, what is shear force? We already studied. Shear force is nothing but only load. We want to consider only load we will consider. So bending moment means load into perpendicular distance, how much distance it acts. So now for that CB portion, shear force is Fx. We indicate the shear force as Fx is equals to W kilonewton is acting CB load. So for that we want to first of all, after considering the portion, we want to divide the section XX. So for that, what is the right hand side? So right hand side is load W. So even though CB is a single element, we want to divide into two like a section XX. At that time, entire body acting as a W kilonewtons. So if we consider the section XX right side, that is there also acting W kilonewtons load only. For that, their entire load is acting at center. See, after this line, we are considering this portion only. This portion also, load is acting at center. Understood? So that is the shear force. Shear force that is plus Wx. So why we are writing x? So we are they discussed shear force means only load. So load how much acting this length is we written here. That is also a load only. How much load how much length load is acting. So in point load we cannot write like that because here load is acting distributed, uniform distributed, for that Wx. So next bending moment diagram. That for that see the right section after the beside the side section XX, right side portion is moving clockwise direction. For that we indicate the minus. So in shear force, when it is moving from top to bottom, at that time we use positive. Here it is moving clockwise direction. At that time we use negative in bending moment. This we already discussed in theory part. Next, load is what? Minus Wx. Wx into x by 2. How much distance from the section XX is here? The load is entire here. How much for section XX distance is x by 2. So it is moving, it is like bending like this. Bending moment means this portion is bending like this toward the section XX. How for that here x by 2. So this length is x by 2. So this length is also x by 2. Then it becomes a x value. No, for that is a x by 2. So minus Wx into x by 2 is our bending moment. So now likewise we want to consider the portion AC. So portion AC, for that we want to divide a section XX. So what is right hand side? Only one load is acting here, that is minus W. That means not minus, shear force means plus W. A, why we are written here A, why here we written X? See here, what is the right hand side? So this entire portion is we are seeing. So before CB portion we are considering, at that time only we are seeing off. For that here load is what? W. How much distance? A the distance of this. For that plus WA is a shear force. Next, bending moment. Bending moment is what? So force into displacement or distance. So minus, see, right hand side is W minus WA, because it is moving in clockwise direction. That means entire this will move. This here now force is acting at its center. It moves into the section XX here. So here minus WA, because it is moving in clockwise direction. So minus WA into X. X minus, here we want to write X minus. Why? Because this X is already we know. X minus A by 2, the portion is divides A by 2, because load is acting at center, for that A by 2. So total is A, for that centrally it is acting load, for that A by 2. Section X is here, this is A by 2, this is A by 2, and becomes A. So see here, so minus WA, X minus A by 2. So next, likewise we consider it as a L, whatever that may be. Next here WAL, we want to into this A or L, we can give notations, anything, no problem. So WAL minus WA square, A square by 2, because we are multiplying this is. So for that here see bending moment W minus WX into X by 2. So X into X what? X square. So for drawing shear force and bending moment diagram, so first of all we want to consider the shear force here. So first to draw a one plane axis line, reference line, and then at point B what is the shear force? Is plus WX is the shear force acting. So that is it is moving plus WX, because here a section XX. So plus WX is we drawn like this. And next portion AC is a what is the shear force? Plus WA. That means when compared to plus WX, plus WA is more. For that we want to increase the line like this. So this is a shear force diagram. So why we are drawing upside means because the values are positive. For that we want to draw a positive above the reference line. So if we draw below the reference line, when means when the values we get negative, that is bending moment diagram, bending moment only. So we want to draw outside, the downward side, that is negative. So why we are drawn like this here? See, whenever there is square and cubic values we get, at that time the shape will be like a curve shape, understood? So here WX square by 2 we get, minus WX square by 2 we get, for that we drawn a curve shape. Or for cubic also we can draw like this only. And then here minus WAL A square by 2. So WA will be cancelled and L square by 2, that means L length. For that we want to just to draw a straight line here. So this is the bending moment. So in next class we will discuss cantilever beam with that means uniform varying load. So after the derivations we move to the problems. So then we can understand the problems. So thank you for watching this video. Please subscribe my channel. Please support my channel. Thank you.